In this particular video, we're going to describe one of the most basic principles in physics, which allows to derive logically a lot of very important concepts, like Newton's laws, Maxwell equations, quantum mechanics, and even Einstein's general relativity field equations. It's crazy. So it's going to be very interesting.
In this video, we're defining the TUP applied to trajectories because it's the most easy to follow application of the TUP. But the TUP is actually even more generic and can be applied to a broader range of applications. But first, let's review what the TUP says. It says that whenever the environment of a particle changes, it changes the potential energy of the particle. And the kinetic energy of the particle will compensate for it so that the action is optimized for the path of an object going from one point to another in a given time. All of this is important. Now, by optimized, I mean, in a very smooth way. And I gave an example of what it means in a previous video. So I suggest maybe if you want to have more precisions, well, just go watch this video. Now, here we can see that there are many trajectories, from the green point to the red one in a given time. But the universe will pick the one with the smoothest changes, again, based on, in particular, the potential energy. Now, in the isomorphic mathematical world, these trajectories are functions, and the differences between function images are called the variations because they are differences between many points at the same time, differences between functions, not points. Because with points, we would just use simple derivatives, So the variation is like the functional derivative, which means the rate at which the action will change as a function of the trajectories, Now here, the trajectories can be expressed as variations of the action. And the action is defined like this, based on the principle that we've just seen above. And so the variations of A will be this, Well, EK is obviously the kinetic energy and EP is the potential energy. And saying that the action of the actual trajectory is optimized is the same as saying that it's equal to zero. So in fact, the universe is better than lazy. Some people call it the lazy universe principle. In fact, the official name is principle of least action. But here we can see it's thrifty, And that will be our first axiom to explain some of the most crazy rules in our attempt for a good physics model. In particular, we'll use it to explain, the stochastic character of quantum physics, general relativity. But again, it can also be used to derive very important other results in physics, like Lorentz equations, Newton's laws, etc., etc. Now, in this example, the EK minus EP expression is called the Lagrangian, and we can generalize it like this. And what's nice about it is that its definition and the definition of the TUP can be generalized under many more complex circumstances, And so using only one principle, we can derive many different interesting results, which will be isomorphic to the physical world, which is our goal, remember? Now, one of them, as we'll see in another video, is general relativity. Wow. And you will easily find derivations, on the net or in books for the first two applications if you're interested. Regarding a quantum physics application, the TUP will help us get some intuitive explanation, about some of the quantum physics mysteries. And we'll see that in the next video. The derivation of general relativity from the thrifty universe principle is a bit more tricky, and so I've made a specific video for that. And of course, there are more applications, but which are not relevant to this series of videos. I mean, there's enough of them. So I'll see you in the next one.